Hi everyone, welcome to UChicago ICPC. Today we will walk through Asia Pacific 2025 Problem L, boarding queue. The problem states, given a grid of 1,000 times 1,000, and there are n travelers in a queue like this, from traveler n to traveler 1. People exit at the front of the queue, so the location of the first traveler will be the boarding gate where people exit. For each timestamp, traveler T will take T minus 1's position. So traveler 2 will take traveler 1's position after one shift. For example, what will the board be after the first time? Isn't that traveler 11 will go to traveler 10's place, and all the people will shift one place forward. 11, 10, 8, 9, 7, 6, 5, 4, 3, 2. And one will exit the queue. For example, the question asks, how many different people will you encounter? Say that you are traveler P. For example, if P is 2, so you start at the location of 2. You are this location. Who will you encounter? At T equals to 0, P, you will encounter 1 and 3, right? The people who are adjacent to you. And adjacent means the 4 cells right next to you. At time 0, you will encounter traveler 1 and 3, right? And who will you encounter at timestamp of 1? Is it traveler 11 and traveler 3? Nice. So traveler 11 and traveler 3. What's the total number of different people? Isn't it 1, 3, and 11? That's right. What is a naive approach to this problem? Idea 1, is it just to simulate the queue, simulate the movement. But what's the time complexity? How many steps will there be? N steps. So n here is less than 10 to the 6 because it's R times C. For each step, how many shifts will we make? Is it we need shift n people, and then shift n minus 1 people, and then shift n minus 2 people. So each step we will shift n people at most, and then check the 4 neighbors. Because if we shift 2 forward, we will shift 3, we will shift 4, shift 5, which will result in n shifts. And then we check who are my 4 neighbors. What's the time complexity? Is it O(n) squared? That's correct. So the first idea is out of the limit of the time complexity. Here is idea 2. It is that we know what our path will be. For example, let's take the example where P is 5. We start at location 5. Then we know we will go through 4, 3, 2, 1 locations, right? Start 5, 4, 3, 2, 1. So we know that what locations I will go. So how can we pre-compute what people will I encounter at each of those future locations? So at P equals to 5, after 2 steps, let's give an example here. P equals to 5. After 2 steps, who will I encounter? Check it out on the graph. Step 1, after 2 steps, we will be at person 3's location. Then who will we meet? Is it person 8 that will travel 2 steps forward and meet us at the location? In addition, we will have a neighbor on the right. And who will take the place of this right cell? Is it number 6, which will move 2 steps forward? Let's draw it. So number 6 will come to number 4, and number 8 will go to the place of number 6. And now, after we reached this location 3 cell, we also have a top neighbor. And who will occupy the top cell? 4, exactly. So person 4 will shift 2 steps forward and occupy the number 2 cell. 2 step will encounter 8, 6, and 2. So after K steps, Who will I be adjacent to? Check the 4 neighbors. Say each of the neighbors is neighbor J. And for each of the neighbors, we will encounter J minus the number of steps. So if J is, we will meet this person. In the example, after 2 steps, we will check the neighbor of this future cell, which are those 2, 4, and 6. So for 6, the minus 2 step will be 8. And for 4, we should, plus 2 steps will get 8, 6. And for the top neighbor, adding 2, we will get 4. So the algorithm is for each of the neighbors before me, for each of the passengers before me. So 5, 4, 3, 2, 1. We only need to check those cells for each I before me, which is P. Check. Hi, how are you? We should check the 4 neighbors. 4 neighbors of passenger I. The 4 neighbors of I say they are J1, J2, J3, and J4. In this example, there will be 6, 4, and 2. Then who will we meet? We just add J1 plus the number of steps we need to get there. So in the example, it was 2 steps. So the neighbor 6 will add 2 steps and get neighbor 8. So J1 add the number of steps, which is P minus I. This is the number of steps. Also add J2 plus the steps, add J3 plus the steps, and then add J4 plus the steps. So for each of the locations before P, we will get all the neighbors there. Sometimes we only have 3 neighbors. It is because here, when 5 moves to location 3, the left neighbor is empty. So an empty cell plus 2 steps forward is still empty. So that's why we don't include that. Also, if we plus multiple steps into the behind outside the range of the line, we also don't add the neighbor. So only add if J4 is non-empty and J4 or any J4 plus PI is less or equal to N, which is the end of the line. So if it needs like person 12 to come here, we don't add those. So what's the time complexity? We only need to check P person, P passengers before me. So which is O, and the greatest of P is just N. So we just check N steps. And for each step, we check 4 numbers. So just N times 4. And finally, we will get an array of all the peoples we encounter, and then deduplicate it. We just use a set that takes O(n) time. So is it just O(n) time complexity, which is 10 to the 6th. Perfect. Thank you for watching.